In this question, we have got two questions and we can write any one among this in the exam. Now let's try solving both of them one by one. Let's look into the first question now. In the first question, they have asked us to check whether the relation R in the set n of natural numbers given by R equals to a comma b, where a is the divisor of b, is reflexive, symmetric or transitive, and they have also asked us to determine whether R is an equivalence relation or not. Now let's start with this one by one. The first one, reflexive. In order to be reflexive, it should satisfy a comma a. Now I'll take that, let a belongs to any natural number n, and from this we can say that a divides a. With this I can say a comma a belongs to R. Since a comma a belongs to R, I can say R is reflexive. Next, let's move on with the second one, which is symmetric. In order to solve for symmetric, let me take one basic example. I'll take let 1 comma 2 belongs to R. Since 1 comma 2 belongs to R, 2 comma 1 should also belongs to R. But if 1 divides 2, 2 cannot divide 1. So with this I can say 2 comma 1 does not belong to R. Therefore, R is not symmetric. Next, let's move on with transitive. Let us take two relations where a comma b belongs to R and b comma c belongs to R. Since a comma b belongs to R, I can say a divides b. And since b comma c belongs to R, I can say b divides c. With this I can say a divides c. As a divides c, I can say that a comma c belongs to R. Since a comma c belongs to R, I can say R is transitive. Now first they have asked us to check whether they are reflexive, symmetric and transitive. We got to know that it is reflexive and transitive but not symmetric. Next, at last they are asking us to check whether it is an equivalence relation. No, it is not an equivalence relation as it is not transitive. I can take out as R is not transitive. It is not an equivalence relation. Now let's look into the second question. In the second question, they have asked us to prove that tan inverse of 1 over 4 plus tan inverse of 2 over 9 is equals to half times of sine inverse of 4 by 5. Now as we can see here, this is of the form tan inverse of x plus tan inverse of y. So I'll take it out here. So tan inverse of x plus tan inverse of y can be taken as tan inverse of x plus y divided by 1 minus xy. Now let's take this out here. Tan inverse of 1 over 4 plus tan inverse of 2 over 9 can be taken as tan inverse of 1 over 4 plus 2 over 9 divided by 1 minus 1 over 4 times 2 over 9. On simplifying, I'll get tan inverse of, by taking a LCM in the numerator as 36, I'll get 9 plus 8 divided by 1 minus 2 over 36, which is going to be 36 minus 2 divided by 36. So I can cancel this 36 in the numerator and denominator. So I'll be left out with tan inverse of 17 by 34, which is equals to tan inverse of half. Now as we can see on the RHS side here, we have got half times of sine inverse of something. So I'll take half outside. So I can take this out as half times of 2 times of tan inverse of 1 over 2. Now We know the formula of 2 times of tan inverse x, which can be taken as sine inverse of 2x divided by 1 plus x square. With this, I can take this is equals to half times of sine inverse of 2x, which is going to be 2 times of half divided by 1 plus half square, which is going to be 1 over 4. Now with this, I can take half times of sine inverse of 1 divided by, it is going to be 4 plus 1, which is 5 by 4. On simplifying this, I'll get this out as half times of sine inverse of 4 by 5, and this is our RHS. Now as we can see here, we started with LHS and we have got the final answer as RHS. This is the proof.